lesson 2.6 is over ratios and proportions, and it starts the second half of our chapter. The last part of our chapter is now taking our prior knowledge of solving equations and applying it to different things. Okay, so this part we're going to apply solving equations to ratios and proportions. So what we want to get out of this lesson is we want to be able to compare ratios and then also solve proportions. Okay, we're going to look at our content standards. Again, they're the same ones that we've been using. We want to be able to solve linear equations, but we also want to be able to explain each step. Okay, so again, we're not just interested in solving the equations, but we also want to understand that process and be able to explain why we can do each step. Oops. Our new vocabulary, and this might not be new to you. Okay, you've probably had these before in the past. Ratio, proportion, means and extremes might be new. You've talked about rates, unit rates, scale, and scale models. And we're going to use all those things when we're talking about proportions. Let's look at our first example. The first thing we want to do, we want to determine whether ratios are equivalent. And again, ratio is just a comparison of two different things. Or it's also a fraction. So it says determine whether 7/8 and 49/56 are equivalent ratios. Justify your answer. Okay, what we're going to do, we're going to take these two and we're going to try and put them in lowest terms. So 7/8, their common factor is 1, so we're going to divide each by 1 and we get 7/8. 49/56 can be reduced by 7, so we're going to divide the numerator and the denominator by 7 and we end up with 7/8. So our answer is yes, they are equivalent fractions because when they're expressed in simplest form, they're equivalent. We get 7/8 and 7/8. So these are equivalent ratios. Okay, so why don't you take a look at, check your progress. We want to determine whether 5/6 and 49ths are equivalent ratios. So I want to see what you are dividing by or what you're simplifying each ratio by. So go ahead and pause the video and try this one. Okay, if you tried to simplify 5/6, you would have found that it is already simplified. It's already in lowest terms. Okay, we divided both sides by 1. 1 was your biggest factor. Okay, if we take a look at 40/49ths, it actually also is in lowest terms. Okay, and its greatest factor is 1. So if we take a look in the simplest terms, they're not the same ratio. Okay, so in this case, they're not equivalent. These two ratios are not equivalent. Okay. Okay. Let's move into proportions. Okay, and again, a proportion is just when you have two ratios set equal to each other. Okay. Now we talked about explaining each step, explaining the process, and that everything you do in math, that there's a reason or there's a property behind it. And when we solve proportions, there is a property. It's called the means extremes property of proportion. And what this says is, in a proportion, the product of the extremes is equal to the product of the means. Well, first, let's talk about what are the means and what are the extremes. Okay? Your means are the middle terms of your proportion. Okay, so if this was our proportion here, 1.5 and 1.2 would be the means. The outside terms are called the extremes, and they are the first and last terms of the proportion. So what they're saying is, if you multiply the extremes together, it should be equal when you multiply the means together. Okay? So let's take a look and see what this actually means. Let's look at this property in action. Okay? It says use cross products to determine whether the pair of ratio below forms a proportion. So here we have two ratios and we want to see, do they form a proportion? So let's set them equal to each other. So we go 0.25 over 0.6. Is that equal to 1.25 over 2? And we're going to use cross products. So we're going to multiply 0.25 times 2 and 0.6 times 1.25. Okay? When you multiply that out, you can see that they're not equal. Okay? So, because their cross products are not equal, the ratios do not form a proportion. They are not proportional. And that is your means and extremes. Okay? Let's take a look at this one. Here are your two ratios. We're going to set them equal to each other and do the cross products. 2 times 20 and 2.5 times 16. When you find their products, you see that 40 equals 40. Therefore, because their cross products are equal, the ratios are proportional. Okay, they form a proportion. Okay, why don't you try you check your progress, A and B. Pause the video, and then we'll take a look at them. Okay, so what do we got here? Let's set them equal. We want to know, is this ratio or fraction equal to this one? Okay, so what we want to do, let's use our cross products. So we're going to multiply our cross products. And when we multiply them out, we can see that they both equal 0.585. Therefore, since the cross products are equivalent, we can say that the ratios are proportional, or that those ratios do form a proportion. Okay. The second one, set them equal to each other to form a proportion. So we're going to do cross products. 5 times 15 and 6 times 12. When we multiply those out, those products are 75 and 72. They are not equal to each other, so those two ratios do not form a proportion. Okay? So that's kind of the second skill of this lesson, determining whether ratios are proportional. We learned how to simplify them. Now we can use our cross products to see if they're proportional. The next thing we want to do is we want to solve a proportion. So if you have ever heard of cross multiply and divide, this is what you're doing. Okay, this will probably be reviewed for most of you. We're still going to use the cross products. So we're going to go n times 8 and 12 times 3. We're going to simplify that and multiply it out. Then we have a one-step equation here. We have to divide both sides by 8, and we get n is equal to 4.5. So we know that 4.5 over 12 is going to equal 3/8, okay, to finish out that proportion. Let's look at another example. We have x plus 4 over 12 equals 3/4. We want to find out, what does that x have to be? Again, we're going to use cross products. We're going to go x plus 4 times 4. Now notice that the x plus 4 is in parentheses. And then 12 times 3. Over here, if we multiply that out, you do the distributive property. Okay? Then we have a two-step equation, so we're going to subtract 16, then divide by 4, and we get 5. So that x has to be a 5 in order for this ratio to equal that ratio. Okay, you have two practice problems. Go ahead and pause the video and try those. Okay, let's see how you did. Okay, here's our proportion. We're going to do our cross products here. So r times 10 and 7 times 9, or 9 times 7, doesn't matter. Go ahead and simplify, and we get 10r equals 63. So to get r by itself, we have a one-step equation. We're going to divide both sides by 10. And when you take 63 divided by 10, you get 6.3. Okay. Now let's look at the next one. This one was like the example B and example 3. Okay, let's use our cross products. Okay, 8 times a quantity x minus 6 and 16 times 5. Okay, so what I did here, I'm solving this one a little bit differently. Might save you a step or two. I took 5 times 16 and got 80. I didn't do the distributive property over here yet. So what I'm going to do, instead of doing the distributive property, I'm going to go ahead and divide both sides by 8. And what happens here is that the 8's over here cancel out. Okay. And what we're left with is x minus 6 equals 10. Then the only thing you have left to do is add 6 to both sides, and you get x equals 16. You could have done the distributive property, worked it out, and had a two-step equation. You'd still end up with x equals 16. That's fine. That's no problem. I just went ahead and I saw multiply by 8, so I'm going to go ahead and divide by 8. Either way, it works fine. as long as you show your work. Okay, let's take a look at a problem here. The ratio of a gear on a bicycle is 8:5. This means that for every 8 turns on the pedals, the wheel turns 5 times. Suppose the bicycle wheel turns about 2,435 times during a trip. How many times would you have to crank the pedals during the trip? Okay, so you need to use this ratio to help you find how many times you'd have to crank the pedals. So here's what you're going to have to set up. Here's your equation, or your proportion. Here's your pedal turns, here's your wheel turns, and you got that from right up here. Okay. It's asking how many pedal turns do you have to do. Well, since this is pedal turns on top, pedal turns has to be on top over here. Wheel turns are on the bottom, so wheel turns have to be on the bottom over here. Then you can just do your cross multiplication. Okay. Here's your cross multiplication. Multiply it out, simplify it, divide both sides by 5, and you get 3,896. Okay. That's how many pedal turns you're going to have to do. Okay. Trent goes on a 30-mile bike ride every Saturday. He rides the distance in 4 hours. At this rate, how far can he ride in 6 hours? Okay, use this part right here to set up your proportion. Okay. Go ahead and pause the video and try it. Okay. Here's what we got. 30 miles in 4 hours. So I put miles on top, hours on the bottom. You could have it flipped, that's okay. But if you have this one flipped, you better have this one flipped. Okay, the distance goes together, the time goes together. All right, cross products, simplify it, divide both sides by 4, and we get a distance of 45 miles. Okay, so if we knew that he rode 30 miles in 4 hours, it's going to take him 45 miles in 6 hours. Okay? Let's look at another example here. This is your scale and scale models. In a road atlas, the scale for the map of Connecticut is 5 inches equals 41 miles. What is the distance in miles represented by 2.5 inches on the map? Now, we've all done this before. Okay? So we're going to set up a proportion, scale to actual. You could actually have it the other way too. It doesn't matter as long as they're the same across. So we do our cross products, simplify, divide both sides by 5, and we end up with about 20.5. Okay? All right. Use the same process to do this problem right here. Go ahead and pause the video. All right, so we're using a scale map of the United States, and we know that 1 3/8 inches is equal to 750 miles. The distance on the map between LA and DC is about 3 7/8 inches. So we want to know what is the actual mileage. Okay, here's going to be my proportion. My inches, my scale is on top, my actual distance on the bottom. Again, you could have that flipped. That's okay. I'm going to do cross products. I'm going to simplify. Then, after I simplify, I need to get rid of, I went ahead and changed this to 11/8. 1 3/8. I'm going to multiply by the reciprocal. And my distance is going to equal about 2,114 miles between the distance between LA and DC. Okay, so that was the last example problem on using scale models, on using proportions to solve different word problems, and just solving proportions in general. So we are actually going to do a lab in class about gears and bike pedals and things like that. So come with your questions on the outline. Okay.